As promised, we're going to do some nice, difficult questions tonight. The next question was sent to us by Carlo Toto. Carlo, thank you for this question. It is what is that? It looks like a 22-mark question, and it deals with a parabola, and then what do we have there? An exponential graph. Okay, so the parabola is f. They've given us this equation for f. And then for g, they said it's 2 times a half to the power x plus 1 minus 4. Okay, now we know what to expect. They say graph f cuts the x-axis, f and g, in fact, cuts the x-axis at, let me get another color quickly, at point A, which is over there. And the parabola cuts the x-axis at C and has a turning point at D and a y-intercept at E. Then finally they tell us the graph G cuts the y-axis at B. Okay, first question, write down the equation of the asymptote of G. Now folks, remember exponential functions do have asymptotes. If we look at the equation of the function here, our asymptote is given by this minus 4. Okay? So if I draw that in, let me find a line quickly there. Let's use the black line. I hope it will draw. That is our asymptote that we are talking about. Okay, so writing down the equation of that asymptote is easy. The equation of the asymptote, I think asymptote has one S. Equation of the asymptote is y is equal to -4. That was for a lousy 1 mark. Then for 2 marks, write down the coordinates of D. Now remember, D is the turning point of the graph. So there's quite a few ways to find that turning point. Minus b over 2a is the one way. The other one is to differentiate the function, make it equal to 0 because it's a turning point. And the third one is the one that they want us to use in this question. They gave us the graph in completed square form. So the second part is for 2 marks. Remember the sign change over here. The turning point lies at point D, and it has an x value of 3 and a y value of 25. So that's the point 3 and 25. And this is the line y is equal to -4 if we need it. Always remember, transfer the information back onto your graph. Okay, now they ask us for the range of f. Now the range, remember, is all the permissible y values on the graph. The domain is the x values. Let's have a look. F is a parabola, so it has a maximum value at 25. So to write down the range of the function f, we can say y is less than equal to 25, and it's all the real numbers that are less than equal. So it's all the numbers as long as it is smaller than 25. Some people like to use interval notation here. Okay, so we can then say y is an element. Let me write this down. The alternative would be to say y is an element that comes from -infinity and goes up to 25 with a closed open bracket. Remember, at infinity, the brackets are always open, and if the point is not included, then your bracket is also open. So that was for 1 mark. Now they're asking us in the next question, they say find the length of EB. Now EB is the difference between the two y-intercepts. So for number 4, for EB, we need the y-intercept at E, and we need to subtract it from, or from that, subtract the y-intercept at B. Okay, how do I find these points? Remember, we've given the equation in completed square form. The 25 is not the y-intercept. Okay, always remember that. Okay, so we need to make x naught in both of these to find the y value. So let's go for the y value of e first. If we make x naught here, so in other words, we want f of 0, and that we obtain by making x naught, so we have minus 3 squared plus 25. Now don't go and say that this is a minus times a minus, which is a positive, okay, because it's not the case. The square has dominion over the first negative inside. So we're first going to square that negative, make it positive, and then multiply with a negative. So this is minus 9 plus 25, and that gives us a beautiful 16. So E is the point 0 and 16. Okay, and then we need the value of the point B. So we find the y coordinate of B. Let me make space for us here. The y coordinate of B, we let x equal 0 over here. Now, if x is 0 there, we've got a half to the power 1 times 2, which is 1. Okay, so here we go and we calculate g of 0, which leaves us with 1 minus 4, and that gives us a result of minus 3 for the y value of b. Okay, now we're ready to subtract those two from one another, and that will give us the length of EB. Let's do that. EB will then be 16. Be careful of the double negative. Okay, so that gives you 19 units, because that double negative makes the negative 3 a positive 3, and that was for 4 marks. So we had to do a little bit of work, so we expect a little bit more marks. Okay, 6.5 says, for which values of x is the function f decreasing? Now let's have a look. Here, is it increasing, decreasing? Everything changes here at the turning point. On this side of the turning point, the y values are increasing. And on the other side of the turning point, the y values are decreasing forever. And we're looking, here it increases, there it decreases. And they asked us for the values of x for which it is decreasing for 2 marks. Okay, so obviously it's to the right of the turning point. So let's give that answer. This is number 5. Sure, I'm writing all over the show. Number 5 is x must be, it's decreasing, folks, remember, not stationary, decreasing, okay? So it has to go through 0. We do not include the horizontal. So x is bigger than 3. Or in interval notation, x is an element from open 3 to open infinity, whichever one of those you would love to use. But it's not equal to, because it is stationary at the point where x is 3. So that was 2 marks. 1 mark will most probably be for excluding the point 3. Number 6, calculate the average gradient between points A and B. Now let's see. We've got the coordinates of B. We found them somewhere over here. So B is the coordinate pair 0 and negative 3. We need the point A to find the gradient between those 2 points. Now, folks, what happens at A? At point A, the y values are 0 because it is an x-intercept of our parabola. Okay, so at this point, we're going to most probably find both x-intercepts, exclude the one that is positive because it's on the negative side. Let's have a look. We want to know where is minus, what is it, a positive? No, minus x minus 3 all squared plus 25 is equal to 0. Now again, grade 12s, you've got a square number there. So don't go and distribute this bracket. Keep it by itself. Throw the 25 over and take the square root both sides. Okay, so let's do that. We see that we have, and I'm going to remove the negative, so I'm going to throw that over the equal sign. So I get x minus 3 all squared. It went positive, is equal to positive 25. Take the square root both sides, x minus 3 as plus or minus 5. And at this point, we need to split it up again. So x is equal to 3 plus or minus 5, and now we need to make our choice. The one choice is x is 8, and the other choice is x is minus 2. We are on the negative side, so we found this point as 8 and 0, but we actually want to work with minus 2 and 0. So the gradient between those 2 points. Okay, so this here again is not applicable for what we want to do. Our gradient, let me just get us some space here, our gradient of AB, now this part of the question is for 5 marks, so they do expect us to do some work here, as you can see. Okay, we've got point A and we have point B. Let's just write them down here. A is the point minus 2 and 0, and B was the point 0 and negative 3. So if I want to use that for the gradient, let's start here. 0 minus minus 3 is plus 3. Minus 2 minus 0 is minus 2. So the gradient between the points A and B is minus 3 over 2. Okay, we've got the point A, we have the point B. Okay, 6.7, the 7th question over here, and then we're back at 2 marks. The graph T is obtained by reflecting G about the x-axis, right down the range of T. Okay, so if we reflect it about the x-axis, it means the y's become minus y's. Okay, the y is what changes sign. So for G, are we reflecting G? Yes. So we have the equation for G is y is equal to 2 times, I'm going to make this question 2 to the minus x minus 1 minus 4. I don't like the half. If I multiply the like bases together, I add the powers. So this is nothing other than 2 to the minus x minus 4. Okay, that's the equation. What happens? We're reflecting it in the x-axis. So the positive y becomes a minus y. That's what happens. Now, all we need to do is take that negative to the other side of the equation. Let's do that. Therefore, y will equal minus 2 to the minus x plus 4. And then they ask us what is the range of t. Now, folks, if you look at the graph, if you reflect this graph in the x-axis, which lies over there, then that graph, let me use black here, that graph is going to lie over there. So the graph has reflected, remember this is your x-axis over there. The graph has reflected, it's taken its asymptote with it. Okay, so now the graph has a maximum that approaches 4. So we can say here that our range for this new function will be all the y values that are smaller than 4, and y is still a real number. So all the y values that lie below 4 goes into that range. Okay, 6.8. Let me make space for us here. 6.8, the question for 2 marks. They say if P is f of x plus 2, write down the turning point of P. Now remember our turning point of P we had, it was at 3 and 25. Okay, so what happens now? We are translating this graph 2 units up. What is moving? The x's aren't moving. it's the y's that are moving up 2 units. So the new graph, P, for P, we will have a turning point 3 and 27. All we need to do is add 2 to the original graph's y values. Then we have translated it upwards. That's for 2 marks. Now this question is what I like. The last one in this particular section for 4 marks. Determine the value of k if the straight line, now they give us the line equation as y equals 2x plus k. So let's write that down. Y is 2x plus k has to be a tangent to f. And the question is, what is k? Okay, we have the equation for f. If we're working with tangents, it means the line touches the parabola. So we're going to put them equal to each other as if the line is a tangent. So let's do that. Minus x minus 3 all squared plus 25 is equal to 2x plus k. Okay, that is what would happen where the two of them will either intersect or touch. So we're making it a simultaneous equation for now. Let's get everything distributed so that we can work with this answer. So I get minus, I'm going to work slowly, x squared minus 6x plus 9 plus 25, throw it to the left, minus 2x minus k is 0. Move the negative in. I suggest, folks, because this is quite a lot of marks you're going to get here, to do this very slowly so you do not make a silly error. Plus 25 minus 2x minus k is 0. Okay, so minus x squared. There is an x and there's an x, and if I add the 2 together, I get plus 4x. 25 minus 9 is plus 16, and then the poor old minus k, it's all by itself. Okay, there we go. So what do I have? I have a quadratic equation. Now let's analyze this. This here is the a value. A is minus 1. Here, our coefficient for x is always the b value, and this is our c value. C is 16 minus k. Now, why is that important? I've got a parabola, I've got a line, and that line has a variable in it. I want these two curves to touch each other. Okay, so what do we know? We must bring the discriminant in. That thing must have an equal root. So the b squared minus 4ac must be equal to 0 in my formula. If I apply the formula here and I just look at that root section is the section that's dangerous. Now, if the two curves touch each other, that root section must be 0. So you have 1. Look at this. You have x as minus b plus or minus the root of this thing, which I'm just going to call delta over 2a. For to have only one root, this plus or minus part must go. When will it go? When the thing that's underneath it is equal to 0. Then the only root is x is minus b over 2a. Okay, let's see what we're going to get. We're going into the next phase. So therefore, b is 16 minus 4 times a. So I'm going to make that plus 4 because it's minus 4 times this minus 1 multiplied by c, which is equal to 0. Now, folks, before you distribute, simplify this thing. There's a common factor of 4 throughout that problem. Okay, so let's remove that comma or divide by 4. Then we get 4. This 4 is 1. So 4 plus 16 minus k is 0. And all of a sudden, this has become an arithmetic problem. The k value has to be 20. So if k is 20 there, Carlo, then you have a tangent. The one curve literally the line touches the parabola. They didn't ask us for the point, they just wanted the value of k. So k has to be 20. Thank you very much for that question.